Understanding Space Weather with help from citizen scientists and Steve. I'm Tonya Hall, and joining me is Dr. Elizabeth MacDonald, space physicist at NASA's Goddard Space Flight Center. Welcome, Dr. MacDonald.
Hi, Tonya.
So, what do you do in your role at Goddard, and how are you involved in space weather?
So I am a scientist at Goddard, and I study how the aurora are born and form and evolve with a variety of different techniques, satellite measurements, ground-based cameras, and also recently with citizen scientists and people on the ground taking real images of the aurora in a project that I founded called Aurora.
Over the Labor Day weekend, people as far south as the 45th parallel had a chance to see and photograph a bit of space weather. Tell us about it.
Yeah, there was actually an event on the sun, not a big flare, but something that happens called a coronal hole. And even though we're at solar minimum right now and the sun is not giving us those flares very often, these coronal holes have particularly high, fast solar wind. And so the solar wind got up to like 800 kilometers per second and hit the Earth, actually maybe 700 or so. And that drives the aurora to go down to lower latitudes and drives a bit of a storm. And so people got to see it. It's really difficult, as we talked about, really difficult to actually tell you when you're going to be able to see it. You kind of have to wait until that coronal hole comes out from the sun via the sun's magnetic field. That's a really long way. The sun is 93 million miles from us. And what really matters is actually the direction of the magnetic field in the solar wind, which enhances or decreases the coupling of the energy from the solar wind to the Earth's magnetic field region called the magnetosphere. And so just like two magnets, when the magnets are in opposite directions, they're attracted. And so we're really looking for the solar wind to have what's called a negative magnetic field component in the direction opposite the Earth's field out there in space, and it's called BZ South. And so when the data from the 1 or 2 satellites that we have that's not 93 million miles away, not all the way at the sun, but 1 million miles away, I'm going to show you my little satellite representative. When that shows us that what direction the magnetic field is and that you have this enhanced velocity, then you can really drive aurora. And if you're in a place that's dark and clear and it's around midnight, you would have a good chance of seeing it, especially around like the US-Canadian border for North America for the last couple days.
Well, in fact, you and I talked quite a bit about the last couple of days as far as, you know, what advice you have for people who are going to try to go out and experience auroras themselves. You referred us to a Facebook page, which was Alberta Aurora Chasers, I believe.
Yes.
And they did a great job of, and you talk about citizen scientists, about helping people understand the best places. We went to northern Idaho, just outside of Creston, actually, Canada. And you gave us some advice on the best places to go. We got to see the aurora ourselves, which was beautiful. It was, you know, beautiful shades of green and certainly some other colors. And talk about, you know, I shared, you saw some of those pictures. Talk about what you saw from citizen scientists and aurora chasers and what they were sharing.
Yeah, I'm really glad that you got to see it and that you got some nice photos as well. It's actually difficult, especially when it's your first time seeing aurora or taking those photos. So having a community of people in roughly your local area, and in this case, Alberta Aurora Chasers, there's a lot of people in the Calgary area, a lot of people who are really dedicated space weather aficionados and photographers, and their Facebook feed is a great place to find the information of who's seeing what right now. We've collaborated a lot with them on our Aurora project to also collect those observations and put them on a map to give people a better way to visualize where that activity is happening. I didn't point you to our page right at the moment because a few things are not working on that, and we're working on it. But in the meantime, especially for that area of the country, Alberta Aurora Chasers are a great resource. And then another thing that happened last weekend is that there was also an unusual new type of aurora visible, or something like Aurora, that we've investigated with the Alberta Aurora Chasers and other scientists, and we call it Steve. And Steve is something, I'm not sure if you saw Steve, but you certainly saw Aurora to the northern horizon, as much of the horizon as you can see. If there's mountains around or whatever, you can see the colors of the aurora. There's a typical green, and then above that there's more of a red emission. Both of those are actually from oxygen in our atmosphere, and they're from the particles from space that are excited in the Earth's magnetosphere and then raining down the magnetic field lines and exciting that ambient oxygen and causing that green and red glow. The two different colors happen at two different altitudes, and you get two different emission lines with different time constants. The altitude, the density also varies with altitude, which controls which wavelength comes out at which time. And so you could see that to the northern horizon, but some of the time people were noticing that there was also something overhead that kind of looks like a contrail. It's kind of gray to the naked eye and very narrow and literally right overhead at those kind of latitudes. And some of these photographers were seeing it, and in their photographs, the camera picks up the colors much better than our eyes can. And it was this odd kind of purple color, not the usual auroral kind of color. And also there's sometimes these green little fingers that we call a picket fence along with it. And that actually turned out to be something new to space science. And we now understand that it's been photographed for a long time and optically observed for a long time. But when we looked with our satellites that were in low Earth orbit at the atmosphere itself and what's causing that, we saw that there's this very strong flow. So STEVE now stands for Strong Thermal Emission Velocity Enhancement. And there's this very strong flow east to west. That's actually been seen in satellite observations for 40 years, but never known to be visible. So it's a new discovery, definitely enabled by citizen science, and it's really energizing people out in the world everywhere, as well as scientists like myself.
Well, I think, we went out the day prior for proof of concept to kind of try to figure out, because as you pointed out, unlike eclipse, you really don't know exactly where you should go or where it should be in order to get, the best view. And I think Steve, we saw the night before, but what we didn't know, and I think is important to point out, Steve has his own Twitter account. What's that all about?
Yeah, so actually Steve is delightful, and the Alberta Aurora Chasers are delightful. So you can follow Phenomenal Steve on Twitter for sightings. And there were several sightings in the last couple days. Manitoba, Alberta. I'm not sure. There could have been some from the Southern Hemisphere as well. I think there were some from the UK, the Shetlands area. I didn't exactly follow all of them, but you should check on Phenomenal Steve on Twitter for sure.
Phenomenal Steve.
Mm-hmm.
Are occurring at some point above the Earth's surface on a regular basis. So how do we study them today, and how is the knowledge gained from following these applied in everyday life?
Yeah, that's a great question. So even though they're always occurring, we do not always know where they are occurring, and there's a lot of dynamics involved that we understand like 95% of all of the processes, but there's still some pieces of it that we do not understand or could be missing, like Steve, and what's that about and how that relates to the bigger picture. So we continue to understand the whole and research the whole phenomena, the whole system. Ideally, we're trying to understand space weather from the sun to the Earth to the point of predictability so that we can protect our satellites and ground-based systems that are susceptible to space weather. And one aspect of space weather, the aurora itself, is generally kind of sheets of current. It's electrons raining down in a broad curtain kind of region, multiple arcs, and those currents can actually induce currents on the ground in pipelines or transformers, or systems on the ground can be affected. GPS can also be affected. And so it is important to better understand all aspects of the system. However, the system is so huge that it's really difficult, and our satellites aren't everywhere. So that's why we really need people to join us. And it's a great sort of use case for citizen science where we can help improve your chances for seeing aurora, and you can share your observations and help us make better models of the aurora. So that's what we're doing at aurorasaurus.org, and definitely keen for more people to join.
This weekend was the 160th anniversary of the Carrington event.
Oh, wow.
Where are we today from the standpoint of understanding the effects of solar activity on the future of technology?
I think as well, we understand the big picture, but there's some gaps, right? So I like to say that we can watch the sun much better than we can actually tell you exactly when the aurora is occurring. When we watch the sun and we see things happening on the sun, it's such a long way away that measurement, like if it's a pixel in an image and you see something hot, you propagate the errors. Everything has some errors. So, you get a measurement of what's happening on the sun, but there's still some uncertainty to that. And then you have to model 93 million miles, and it's a really challenging problem. As well, there are some quantities that are very important to understand the effects, like the magnetic fields, that we cannot get currently by looking at the sun remotely. So that's also really important. So all of space weather is improving, but also a research field. So that also makes it really exciting.
Dr. Elizabeth MacDonald, space physicist at NASA's Goddard Space Flight Center. If somebody wants to connect with you, Liz, or maybe they want to find out more about Aurorasaurus, how can they do that?
Well, aurorasaurus.org is our website, and Aurorasaurus is on Twitter at @tweetaurora, and I'm on Twitter at SpaceyLiz. So welcome to hear more from people there.
Love your Twitter account, Liz. That's great. If you guys want to find me, you can do so right here, or go to tonyahall.net. Thanks for watching.